Well, hi, hello, namaskaram. Myself Mahesh Prasad from Department of Physics. As you know, well, dear students, we are in a chapter that is nothing but oscillation. Under this particular concept, we have discussed many topics like we have discussed period oscillation with respect to frequency and different types of oscillation. We have discussed like a simple harmonic motion. We have discussed, and in the previous class we have discussed about what could be the velocity in terms of simple harmonic motion as well as acceleration in simple harmonic motion, and we have discussed in which particular point velocity is maximum and in which particular point acceleration is maximum. So right now your job is to get what could be the expression for total energy. So before we get into this, what do you mean by total energy? By the way, it is sum of kinetic energy and potential energy, right? So whenever we speak about total energy is equal to sum of kinetic energy and potential energy. Now, so to get the total energy, we need to calculate. Initially kinetic energy. Initially we supposed to calculate this kinetic energy, and later on we supposed to calculate potential energy. By having these two energy, we will try to get total energy. I have written something on the board that is nothing but expression for kinetic energy. Correct? So, what do you mean by kinetic energy? By the way, imagine this part. There is a bob we can expect. So, there is a bob which is with the thread over here. Now. According to your knowledge, it is the mean position and this could be the extreme position. Now, if I allow to make this particular bob somewhat like this with the oscillation, to and fro oscillation or to and fro motion. Now, your job is to check in which particular point velocity of this particular bob is maximum, whether it is the extreme position or in mean position. By having the mathematical idea, we will try to prove that in which particular point this particular bob can experience maximum kinetic energy, whether it is a mean position or in extreme position. Understood? So we will try to prove that. So in our previous class we have discussed about displacement relation, that is nothing but displacement relation as y is equal to, that is a sin omega into t. Yes or no? Yes. So this was the relation we have got as a displacement relation. What do you mean by velocity? I can explain. Velocity is equal to, it is a differentiation, that is a dy by dt which is equal to this. What would be the differentiation of a sin omega t? I can expect. Since differentiation of a sin omega t or sin x equal to cos x, in the place of x what we have? Omega t we have, correct? So altogether I can expect a omega cos omega t. Why this omega is comes into the picture here? Because omega t, once again your job is to differentiate. Okay? So if you do so, we can expect the sin omega t we can expect. Correct? Well, so now what is the formula we can expect in terms of kinetic energy? That is nothing but half mv square. So the kinetic energy can be, that is half mv square. But what is the value of v you have? It is a omega into cos omega t. Correct? Well, substitute the value. That is a half m. What is the v can be? That is a square omega square cos square omega t. Now, according to your knowledge, can I take a square and omega square outside? So it becomes what? There is a half m a square omega square. Now what you can write? There is a cos square omega t can be taken as what? According to your knowledge, can I take sin square theta plus cos square theta is equal to 1? But here, with respect to cos square theta, can I write that looks like 1 minus sin square theta. So similarly, this cos square theta can be taken as 1 minus sin square omega t. Correct? Now if I multiply A inside the bracket, what we can expect is very simple. It is half m omega square of, it is a square minus a square sin square omega t, correct? So a square sin square omega t can be replaced by what? It is nothing but a y square. So it is equal to, that is the kinetic energy, which is equal to half m omega square of a square minus y square. So because why? Because a sin omega t is nothing but y over here. Since we have a square sin square omega t can be replaced by what? It is nothing but y square. So this is the expression for the kinetic energy we can expect. Correct? And similarly, your job is to get in which particular point your kinetic energy is maximum. Let us say at mean position, at mean position in a sense, if I say that is nothing but right now your bob is in the mean position. And here this could be the extreme position. Now, do you think, if I say this is the mean position, do you think your bob is displaced with respect to mean position? No, because your bob which is there in the mean position, do you find any displacement? No. So I can expect y is equal to 0. If I make y is equal to 0, what is the kinetic energy? The kinetic energy is equal to how much I can expect? It is half m. That is half m omega square into a square. So this would be the maximum kinetic energy. You in which particular point you have got maximum kinetic energy? Where y is equal to 0, which means when I leave above somewhat like this, when it passes the mean position, which can experience a maximum kinetic energy. Similarly, which can experience maximum velocity. So think about in terms of extreme position. At extreme position, what would be the value we can expect? What would be the value? That is nothing but y is equal to a. So if y is equal to a, which means displacement is equal to amplitude. What is the amplitude? It is nothing but a maximum displacement. Yes or no? Well, so now what would be the kinetic energy I can expect? Where y is replaced by a, which means a square minus a square gives what? 0. 0 into anything is how much? 0. What would be the kinetic energy at extreme position? 0. Understood? So this is how exactly we can expect in terms of kinetic energy expression over here. And similarly, we can expect the expression for potential energy. Okay, so that we'll see over here. Now, perfect. So if I see about expression for kinetic energy, let us try to prove that. That is the expression for potential energy in simple harmonic motion. Simple harmonic motion. So what is the expression we can find over here? What is the expression we can find? Is very simple. We will try to prove this. What is the acceleration we can find, by the way? Since we have velocity, what would be the acceleration we can find? That is nothing but once again your job is to substitute and get the answer. That is nothing but your acceleration will be, that is dv divided by dt, which is equal to, what is the velocity we had? A omega cos omega t. If I differentiate this, what is the differentiation of cos theta? Is minus sin x. Correct? So now, if I do the differentiation, what I can expect over here is very simple. That is nothing but that is minus a omega square sin omega t. Correct? So, but the thing is, a sin omega t can be replaced by what? That is nothing but which is equal to minus omega square into y. So, this is the formula we can expect. But think about this force. think about this particular, imagine this could be the value we can expect over here. So right now we can expect, so let us take a bob over here. Your bob which is there in a mean position, and if I displaced with respect to mean position, this could be the extreme position. Now your job is to answer my question. What could be the force? Don't you think when I hold somewhat like this, don't you think if I leave, this bob will move towards the mean position, which means at this particular point, the one more force which is acting, that is nothing but restoring force. What do you mean by restoring force? It is a force which is responsible, which is try to regain its original configuration. It is called as what? A restoring force. Okay. So now, what is the formula we can expect? F which is equal to m into A. Correct? So A can be replaced by what? That is nothing but which is equal to minus m omega square into y. Correct? So now, your job is to do a work. So if I want to hold this particular bob at this particular point, don't you think I need to do some work? What is the formula we can expect for work done? That is nothing but F work done is equal to force into displacement. Force into displacement. So work should be done against the direction of this particular restoring force. So this could be minus. So minus into minus plus. So what happens here? Which is equal to m omega square y into dy, which is equal to w. Okay. So now this is a small amount of work done we have done. But how to get the total amount of work done? This is a small amount of work that we have got. But if we want to hold at this particular point over here, we need to do a total amount of work done by using a method called as integration. What do you mean by integration? Integration is nothing but it is a process of adding from initial point to final point. So the representation of integration, and it looks somewhat like this. So initially bob was there at this particular position, and we can expect bob can reach, this particular bob can reach out over here, which means 0 to y we can take, 0 to y we can take, yes or no? Yes. So now, what could be the differentiation I can expect? Where here, m omega square of y into dy 0 to y, what could be the formula we can expect? Integration of x power n. What is the value we can expect? That is nothing but integration of x power n into dx is equal to x power n plus 1 divided by n plus 1. In the place of x, what we have? Y. In the place of n, what we have? 1. So what would be your answer over here? That is nothing but m omega square, that is y square divided by 2, which is equal to w. Correct? So now your job is to apply the limit, upper limit minus lower limit. What could be your answer? That is nothing but since we have a limit, that is nothing but 0 to y is equal to apply upper limit, that is y, wherever y is there, replaced by y. So m omega square y, which is equal to w. So this is into omega square into y square. So y square comes in the picture because we have done the integration. In the place of y we have x power n. That's why integration of y is nothing but y power 1 plus 1 divided by 1 plus 1, because it becomes what? Y square divided by 2. So altogether we can expect whatever work we have done, which stores in terms of kinetic energy, which stores in terms of potential energy. So the total potential energy is equal to, that is a half m omega square into y square. So this could be the formula we can expect in terms of potential energy. And we try to find, well, so your job is to check now in which particular point potential energy is maximum, in which particular point your potential energy is minimum. Well, I have a bob which is there at a mean position, and if I displace this could be in extreme position. Yes or no? Yes. So now at mean position, what could be the displacement we can expect? That is nothing but y is equal to 0. If y is equal to 0, think about a potential energy expression. If y becomes 0, 0 into anything is 0, do you find potential energy at this particular point? This in the sense at mean position? No. So I can expect potential energy at mean position is 0, and similarly at extreme position, what could be the displacement we can expect here? It's very simple. We can expect the potential energy is equal to, don't you think this displacement which has reached up to maximum point which can cover amplitude, so I can expect y is equal to a, I can expect if y is equal to a, what could be the potential energy? So I can expect it is nothing but half m omega square y square I can expect, correct? So this is what exactly we can expect in terms of a potential energy over here. Got it? And so here onwards what we can conclude? In mean position which energy is there? Kinetic energy is there. In extreme position, potential energy is there. So here onwards I can say when a bulb moves towards extreme end, it can experience what kind of energy? What kind of energy increases? When a bulb moves towards the extreme position, potential energy increases. What is going to decreases? Kinetic energy decreases. Understood? As a bulb moves towards the mean position, your potential energy decreases and kinetic energy increases. So this is what exactly we can expect in terms of potential energy and kinetic energy. By having these two ideas, we will try to find the total energy over here. Okay? Well. Well, we'll try to get expression for total energy as I told in the beginning. So what do you mean by total energy? By the way, total energy is nothing but it is the energy of a sum of kinetic energy and potential energy. Anyhow, we have got kinetic energy as well as potential energy by having the different idea. So by applying all the values or all the equations which we have got in terms of kinetic energy as well as potential energy, we'll try to apply over here. So according to the knowledge, that is the total energy is equal to, that is the sum of kinetic energy and potential energy, which is equal to, what is the kinetic energy expression we have got over here? That is nothing but we have got, it's a half m omega square of a square minus y square plus, that is nothing but we have got, that is a half m omega square y square. Yes or no? Yes. So if I multiply half m omega square inside the bracket, what we can expect? We can expect that is half m omega square a square minus half m omega square y square plus half m omega square y square. So which other term will get cancelled? This term and this term will get cancelled. What is remaining? So the total energy would be, there is a half m omega square a square. Yes or no? Now according to our knowledge, your omega can be replaced by what? And anyhow this could be the final expression for total energy. I'll make it as a box. This could be the final energy expression. But if I want to get in terms of frequency, so can I substitute this total energy is equal to, that's a half m 2 pi f whole square into a square I can expect. Correct? Well, so if I square this, what happens? What we can expect over here? We can expect, well, energy is directly proportional to the frequency and energy is directly proportional to displacement. So as the frequency increases, energy also increases. As the displacement or amplitude is increases, energy is also increases. Since mass is kept constant. And this is how exactly the basic relation we can expect in terms of total energy under kinetic energy and the potential energy. So your job is to remember in this particular video is very simple. In which particular point your kinetic energy is maximum and in which particular point your potential energy is maximum. In which particular point? Obviously, whenever we speak about in terms of the bob over here, this is a point where kinetic energy is maximum and this is the point where your potential energy is maximum. Understood? So this is how exactly it goes. As the bob moves towards the mean position, potential energy decreases and which energy increases? Kinetic energy is going to increase. So the basic concept we can expect under this is this. Well, thank you very much. We will see in our next class.